All right, we're going to remind you about parametric curves. So I've got this curve here that's defined parametrically. The way that, and I've got the graph over on the right, which is I thought was nice. But just to remind you, the x and y values you could get by making a little table. You have t, x, and y. So you might have something like this. When t is -1, x would equal 2, and y would equal 3. And so over 2 up 3, apparently that's this point right there, is that. Then when t is equal to 0, x is equal to 0, y equals 0, so that's right here. So this is t equals -1, t equals 0, etc. So that's the way the graphing would work. But more importantly, how do we do with some of the calculus? So remember that dy over dx in this case is dy over dt divided, just using the chain rule here, dx over dt. And so this, just do our derivatives. Dy over dt is going to be 6t, and dx over dt is 3t squared minus 3. So what's the slope at this point? Well, I need to know what t is. So t is equal to what? Okay, well, let's use this 12 right here. So y is equal to 3t squared. 12 is equal to 3t squared. T squared has to equal 4, so t is equal to plus or minus 2. Well, is it plus 2 or minus 2? Well, let's find out. When t is equal to, I guess we can go back up to our chart up here. When t is equal to 2, positive 2, we know that y is 12. X is going to be 8 minus 6, which is 2. So I guess that's the one. So it's positive 2. So t is equal to 2. And then we'll just plug that in here, dy over dx. So here, I'll just put that down there. Is going to be 6 times 2 over 3 times 4 minus 3, which is 12 over 9. So 4/3. It kind of, I mean, it's kind of not to scale, but you can see it as a positive slope over there. Okay, what about the area? Well, the area, and I give you the, if you didn't know that, you could always figure out where this crossed. So that's t equals plus or minus radical 3. There's a variety of ways of finding out where it crosses, but the most obvious is that you can see that the x value there is 0. So we could solve for t using the x coordinate. But anyway, the area is the integral of y dx. So if you remember this, then that's pretty straightforward, that's the way this is going to work. And so in this case, you're going to do the integral from negative radical 3 to 3 of y, which is 3t squared, times dx, the derivative of x, 3t squared minus 3, dx over dt, 3t squared minus 3. So there it is. So that's what I'm going to be working out. Do a little bit of algebra first, otherwise you're going to be sad. So this is going to be 9t to the 4th minus 9t squared, a nice even function. So let's see how that works out. So 9/5 t to the 5th minus 9/3, which is just 3 t cubed. And the trick with the integrals of an even function is that, I'll write it out. So this is 9/5 times radical 3 to the 5th minus 3 times radical 3 cubed minus, it's basically going to be the same thing, but with the negatives there. But, you know, I've got the technology, I might as well use it. Yeah, there we go. Okay. Put the negative here, negative there. Okay, there. So this ends up being, because of the double negative, this ends up becoming 18/5 radical 3 to the 5th minus 6 times radical 3 to the 3rd. And there you go. Okay, what about the arc length of the loop? Well, here, arc length is the integral from a to b of the square root of dx over dt squared. It's the distance formula, dy over dt squared. So that's how we're going to do arc length. So this is going to be the derivative in the x direction. Where was that? Oh, there it is. 3t squared. And then the derivative in the y direction, which is 3t squared, derivative of 6t. Okay, so I should probably put that somewhere near here. Dx over dt is equal to 3t squared minus 3. dy over dt is 6t. Did I get that all correct? I hope so. Okay, let's see if this works out nicely. Okay. Squaring a binomial, hopefully you know how to do that. 9t to the 4th, twice the product of the two terms. 9 plus 36t squared. And then some magic will happen here. So after doing a little bit of algebra, we get this. This is so beautiful. I'm just going to shove this up here. So this ends up being negative radical 3 to radical 3 of 3 times t squared plus 1. This here, that is t squared plus 1 quantity squared. And because t squared is always positive, t squared plus 1 is always positive, we don't have to worry about the plus or minus nastiness. Okay, now I can just go ahead and do this. So this is going to be t cubed plus 3t evaluated from t equals negative radical 3 to radical 3. Let's go ahead and plug and chug this thing. So radical 3 cubed plus 3 radical 3 minus negative radical 3 cubed plus 3 times negative radical 3. So this all ends up becoming 12 radical 3. All right, we'll save that last one for the final video.